Alright, hello everyone, it's Mr. Crozier. I'm going to go over practice test 2 with you. The test is posted in the classroom and so is the answer key. Sorry about the light copy here, but this is all I have here. There's a actual copy of it in the classroom. Problem number 1 here. Our job is to find a polynomial with roots plus or minus root 5 and I. And you'll see what I did here is I put the root 5 and the root 5 here. One is plus the root, one is minus the root. And again, when you have a letter I, you always have to put plus 1 and minus 1. It's not listed here. You'll notice they're not listed there, but they do happen. So when you do these problems, make sure you write them all out and you account for both the positive and negative I. Then it's just a matter of foiling. I would foil these two and foil those two. Number 1, write the linear factorization form and list the roots. Well, here's the whole form with all of the solutions. And notice the first step I did is factor out a 5. That has nothing to do with the roots. These are still the 4 roots. The 5 is just out there. Number 3, our story problem, one of our really only applications this time with the E and the I and Z. Be careful this time, they give you the I and the Z, and you're asked to find the E, so it turns into a multiplication problem. When you have an equation, you always have to be careful where your variables go and what you're looking for. Number 4, I first multiplied these two, got this. And then I subtracted, got this. So here's my trig number with a 2-step multiplication and division problem. However, it does say to convert. So I went ahead and took it down to standard form there. Number 3, plot them, add them, plot the sum. The sum is, remember this is like the plane vector and the wind vector, and it's the direction in the middle. Number 7, De Moivre's theorem. I change it into a trig number. A squared plus b squared is c squared, inverse tangent here. And when you do this inverse tangent, doesn't matter what you get right here. You don't have to fix this. This does happen to be on the unit circle or in between 0 and 360, but it doesn't have to be because it's not my final answer yet. And then once I have this in trig form, remember the power goes here and I multiply this by 7. So the way I remember it is, please excuse my dear Aunt Sally, and the real part gets the exponent and the theta gets multiplied just one step down. So exponent, multiply, and there you have it. Problem 7 here. We have a quadratic equation. We're asked to put the height over there, and we need to solve it and see if it reaches it. But all that matters is the number that's under the radical right there. And in this case, the number under the radical turns out to be a negative 320, so that is an imaginary number. And we're talking about a toy plane here, so we don't have a real height for this one, or a real time here. It's an imaginary time, so the plane doesn't go that high. Number 8, I factored out x cubed, and then I could just factor this normal, and look how I wrote this. X, 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 x. You can see all 7 x's right there. There's 7 solutions. 1, 2, 3, 4, 5, 6, 7. The first 3 are 0, then there's 2 of these and 2 of those, so always want to write them out that way. Number 9 says evaluate, so I went ahead and divided this number, so I divide this and subtract this, and I wound up at negative 370. Well, I need a final answer. Now, I could do De Moivre's theorem here if I had to. If I had to do this work, that would be okay. However, I need a final answer, so I have to add 360, and that put me at negative 10. And then I add 360 again, which puts me at 350. which is on one lap of the unit circle. So just keep that in mind. A lot of times you'll see that we're going to simplify our answers till they fit in one of these categories. Top one for the degrees, bottom one for radians. And notice right here, I left it as a trig number. Problem number 9 says just evaluate. I don't have to convert it. Up here on number 4, I did have to convert it. Down here, don't have to convert it. Just leave it right here. This is my trig number. Life is good, and I'm done. Number 10, finding square roots. Takes de Moivre's theorem. I found the r value. I found inverse tangent. And now this 41 is going to go to the half power. And this cosine right here is going to get times by half. I'll show you that on the calculator. Let's see here. Inverse tangent of 40 divided by 9. I'm in radians. I'll go ahead and put it in degrees just so it matches. Inverse tangent 40 divided by 9. And there we go. There's where the 73 comes from. Again, I'm going to use this in my calculator. So in my calculator, I store it into x. So I have that stored into x. Now I'm going to go 41 raised to the 0.5 power. And cosine of that x1 on your calculators, you're probably storing it into a times 0.5. And there you go. And there's where the 5 comes from. And then I should be able to just type in the same thing again, put sign there, and get 4. And then remember, square roots are always positive and negative. If we were finding the square root of 16 in a problem, we could say it's plus or minus 4. Alright, down at the bottom, square root of negative 25 is 5i. I to the 22nd power, well, let's see here. I to the 22nd, 22 divided by 4, because remember 4 i's turns into 1. So how many 1's are in there? That's 5. And then now I just finished the problem. That's 20 minus 2 is remainder 2. So I have a bunch of 1's. So let me write that out. 1, 1, 1, 1, 1, and 2 i's left over, because there's my 2 i's that are left. Well, this is just 1 times 1 times 1 times 1. That's just 1. Don't need to worry about that. I times I is negative 1, so it's negative 1 times 1. It's negative 1. You can FOIL these two, simplify all your parts. Alright, on to the next page, number 12. If you're having the absolute value, it just means the distance from 0. Just take the Pythagorean theorem. Number 13. Well, I had to evaluate, so I multiplied these together. And I came up here. And then when I divide these complex numbers, I take 1 minus 4i times 1 plus 4i. And what that will do, if you multiply it by the conjugate, there will be no more i's. You have a 17 down there. Number 14, it tells you that a complex number has magnitude 6 and angle theta, so they just told you what the format was instead of writing out the number for you. I plotted it, and then I wrote it in rectangular form. And rectangular form means a plus bi. And notice, you are not told to round in this problem. You don't see rounding here. So what we want to do is avoid rounding, and that comes from unit circle values. 15, factor by grouping. Get all the parts together. Let's see, this is x to the third. 1, and you can count the x's. There's 1, 2, 3, and solutions. 16, distance means you subtract them, and then Pythagorean theorem. Midpoint means you add them and divide by 2. Alright, and you should be able to see that when you graph it. Number 17, I plotted it, and then I converted to standard form. And notice again, now we can round. So we have some rounding here, so we're going to round. And this is probably one of the hardest things on the test. When I do this, when I go, let's see here, I'll do my inverse tangent, -2, let me put it in radians real quick, radians, inverse tangent -2 root 3 divided by 5. That number is not on the unit circle. It's not in my interval. So what does that mean? Well, it means right here we are dropping 0.6 from 2 pi. So I'm going to have to hit plus 2 pi, and that's where that number comes from. You always have to check when you use inverse tangent what quadrant you're in, and it's really simple. If you're in quadrants 2 or 3, you add on pi or add on 180. If you are in quadrant 4, you add on 2 pi or 360. And if you are in quadrant 1, everything is okay. So these two quadrants are both over here. This quadrant is 2 pi, that quadrant is okay. Alright, and the last one, we have a function, and our job is to take this and put it in place for x and rewrite it. And notice I'm going to have to FOIL this first and then times it by 2 when I'm all done here. And make sure you notice you're subtracting 2 and you're subtracting -5, which is +5. Alright, hope this helps. Study this for the test. If you have any questions, you can come in before the class, and good luck.